Islamabad Electric Supply Company, a pivotal entity in Pakistan's energy sector, serving 3.2 million consumers across its network. Known for its commitment to reliability and innovation, it plays a crucial role in ensuring uninterrupted power supply to the region. With a legacy of service excellence, IESCO is embarking on a groundbreaking project to upgrade its metering infrastructure in Rawalpindi, supported by funding from the Asian Development Bank. IESCO is set to replace outdated meters with advanced metering infrastructure, or AMI meters, throughout Rawalpindi. This initiative aims to enhance operational efficiency, improve billing accuracy, and empower consumers with real-time energy usage data.
Absolutely, the transition towards AMI meter is a significant milestone for IESCO and its consumers. These meters will not only will eliminate the need of the manual reading, but also provide us useful insights in consumption of energy and its patterns, and help us in the management of resources.
For decades, the city's power distribution relied on traditional system. This system will be digitalized in this project to minimize losses. Such a large-scale rollout requires strict safety precautions to deal with high voltage. Each team's supervisor ensures these precautions are in place before starting work.
सेफ्टी हमारा अल्हम्दुलिल्लाह जो है ना बेहतर होता है, बेहतर के बिल्कुल ठीक होता है सेफ्टी का ग्लव्स श्लव्स होते हैं,
We
हेलमेट।
strictly ensure safety during our work. Before starting any job, we make sure that each technician is equipped with the necessary safety gear. Every technician must wear safety gloves, helmet, and safety shoes to protect themselves against electrical hazards and sharp objects.
To spread awareness about the new AMI meter installation project, the AMI project staff conducted a media briefing. Various TV channels and press reporters were invited to learn about the project and educate the public on its benefits. AMI officers regularly organize training sessions for installation contractors to enhance their skills and effectively address work order issues. During these sessions, experienced officers train contractors on the precise removal of old meters and the accurate installation of new ones, ensuring that the consumption data from the old meters is correctly reflected in consumer bills. IESCO has set an impressive target, installing 1,200 AMI meters every single day. This target is not just a number. It represents the collective effort and dedication of numerous teams working tirelessly.
टारगेट हमारा 1200 का था कि 1200 आपने करना है। हमारा गर्मियों से पहले टारगेट
Before the onset of summer, we were consistently achieving our target of installing 1,200 AMI meters per day. However, the extreme heat has impacted our progress. The scorching temperatures have made it more challenging for our teams to work efficiently, and many consumers are reluctant to allow ins.
The rush to meet this daily target has led to mistakes during installation, resulting in meter malfunctions and burns. All the burned meters were sent back to the manufacturing company for analysis. After a thorough investigation, the company found that improper installation practices were the cause of the damage. One of the key features of advanced metering infrastructure is its ability to send meter data to a central data center. This data transmission can occur through power line communication or via 2G and 4G technologies. To ensure these smart meters comply with national regulations, each model must receive type approval from PTA. This approval process guarantees that the meters meet the required standards and are safe for deployment. When shipments of smart meters arrive, a certificate of compliance must be processed through the PTA. This step involves whitelisting the IMEs, paying the necessary taxes, and finally, releasing the shipment for distribution.
As telecom has a very crucial role in this project, and our meters are mainly PLC based or 2G 4G based, so we have to get type approve of these models of the meters from Pakistan Telecommunication Authority, and later when shipment arrives at the port, so to release the shipment from the custom, it is mandatory to get the COC certificate of compliance from PTA, and we do this compliance and whitelisting of the IMEI at every shipment.
State-of-the-art data centers have been established to support the AMI project. The main data center is located at the head office, with a backup data center situated in Gujikon. To ensure uninterrupted operations, these data centers are supplied by 2 different feeders, along with backup generators and to UPS systems. Advanced fire suppression and VASDA systems are also in place to protect the facilities. The dedicated data center staff continually monitor operations to ensure the smooth functioning of the AMI system, contributing to efficient and reliable energy management. Every morning, AMI officers head out for monitoring to ensure that field installations and contractors' work meet stringent quality standards. Vigilant daily oversight is crucial to promptly identify and address any issues. Without constant monitoring, any lapses in the field can lead to significant setbacks. One critical challenge is the presence of non-commissioned and incorrectly commissioned meters. These problems often arise when meters on one transformer are mistakenly commissioned with a data concentrator unit DCU of another transformer due to common neutral connections or incorrect GIS data. Furthermore, non-commissioned DCS or those with inactive SIM cards fail to communicate with the head-end system, causing data gaps. Transformers lacking DCS disrupt the complete mapping of the feeder, preventing accurate assessment of feeder losses. Through meticulous monitoring and proactive problem solving, it is essential that the AMI system operates seamlessly, maintaining the project's integrity and achieve the project targets.
The AMI meters having PLC module, basically it operates on a neutral and a phase. In single phase, it is L1 and neutral, and on 3-phase, it is L3 and neutral. So, generally, if we see that it is communication, it will work to 2 wires. One is neutral, another is phase. If 2 transformers having common neutral, then the AMI meters will have 2 paths for its communication. Maybe one through transformer T1 and another to transformer T2. So the meters which are near, for example, the meter which is physically connected with transformer T1, but it is physically connected with T1, but it is near to T2. So the strong signal will be through T2, which is wrong. Why it is wrong? Because the parent-child relation of the transformer and meters, they have a perfect relation that if it is connected, a meter is connected with T1, it should communicate with the HES through T1, not with T2. So by this way, if the neutral is common, communication will be scattered, there will be weak communication. So better to open the neutral so that the meter having with transformer T1 should communicate through T1 to the HES, and the meter connected with the T2 have proper communication with T2 through HES. So it is very essential to remove this common neutral so that every meter should operate properly according to parent-child relation.
In the bustling port city of Karachi, a significant shipment has just arrived from China. This shipment, carrying advanced AMI meters, is a critical component in the modernization of the electrical grid. The journey begins at the seaport, where the shipment undergoes meticulous inspection. The meters, packed securely in pallets, are carefully unloaded and transferred to customs for clearance. With all approvals secured, the shipment is ready to move. Trucks are loaded with pallets of AMI meters, embarking on their journey from Karachi to the IESCO regional store. Upon arrival at the IESCO regional store, the meters are carefully unloaded. This store, a hub of activity, plays a pivotal role in the distribution and management of these advanced meters. The next step in the process is the generation of good receiving notes GUNs. These documents serve as a formal acknowledgement of the received goods, detailing the quantity and condition of the meters. The store staff meticulously input data into the system, ensuring that each meter is accounted for. This process is essential for maintaining accurate inventory records. The storage facility is organized and secure, designed to keep the meters in optimal condition until they are needed. Special M2M SIM cards were procured after thorough consultations with telecom operators, carefully selected by the telecom engineers of the AMI project. These SIM cards are designed to ensure reliable and secure communication within the advanced metering infrastructure. SIM cards are issued according to need of installation contractors. Before they are handed over, IESCO processes activation requests with telecom operators, ensuring the SIMs are ready for immediate use. Over 50,000 smart meters have been successfully installed as part of the AMI project, and the majority of these meters have already started communicating with the central system. This marks a significant achievement in modernizing the energy infrastructure. However, with this progress comes new challenges. The complaints burden has shifted from the traditional method to the AMI staff, reflecting the complexities of this advanced technology. On average, more than 100 complaints are now being received daily, requiring prompt attention and resolution. The most complaint reported is the disconnection of supply due to the terminal cover being open. Another significant complaint is that meter change orders MCOs are not fed into the system promptly, leading to consumers being billed for extra units and potentially shifting to a higher tariff slab. Similarly, for some consumers, the export energy function on their meters is not enabled timely, resulting in their net metering units not being reflected in their bills. Another significant complaint is display wash, where the meter's display becomes unreadable or goes completely blank.
Actually, the type of terminal cover complaints we receive are two types. One is due to the contractors we hired do not tighten the terminal cover properly. So after 24 hours, the meter automatically go to disconnection. The second type is that some consumer try to open the terminal cover, which is illegal and are considered as a tampering attempt. So we have strict rules for those consumers, and we deal with those consumers according to a commercial procedure drafted by NEPRA.
The journey of the AMI project began in 2012 with a visionary idea to revolutionize energy management. By December 2014, the feasibility study was approved, and in November 2016, Executive Committee of the National Economic Council (EC) and EC approved the project. However, challenges soon emerged. The procurement process, initiated in March 2017, was halted by the Ministry of Energy in January 2018 due to financial concerns and doubts about the technology. In October 2018, a new government breathed life back into the project, but the onset of the COVID-19 pandemic caused further delays. Despite the setbacks, a second procurement began in January 2019, with 4 bidders stepping forward. By March, only to remain in the race, and KT Kaifa emerged as the lowest bidder. Court cases and the pandemic extended the timeline, but finally, in November 2021, Executive Committee of the National Economic Council reapproved the project. The proof of concept was tested by installing 500 meters in January 2022, focusing on the communication technology, specially Power Line Communication PLC, which passed with flying colors. On September 1, 2022, the contract was signed, marking the beginning of a new era in smart energy management. With the contract signed and the technology proven, Islamabad Electric Supply will install 1.2 million smart meters in 3 years. Indra, a Spanish company, which will provide billing system, introduced a temporary deployment system TDS to create and resolve work orders for replacing old meters with AMI meters. This system will eventually feed data into the final billing system. However, a recent glitch in TDS resulted in a loss of data over the last 3 days, with no backup compiled by Indra. This has led to major issues, particularly with the pending meter change orders MCOs for the upcoming batch. On the other hand, the contractor hired for the Kant Circle Micro Tech Industries MTI has made the situation more difficult. Mismanagement and a lack of permanent staff have further complicated the situation. Replaced meters are scattered across all 3 floors in their office with no segregation strategy, and the absence of proper paper records makes resolving MCO issues even more challenging. During the TDS breakdown, the details provided by the contractor for meter changes was also incorrect. Only 600 meters were detailed, while the actual number exceeded 2,000. In the current scenario, resolving work orders for batches 4 and 5 isn't possible. However, meter segregation is completed, new meter numbers are recorded, and old meter readings are captured. The data is organized into Excel files to facilitate the meter change orders MCOs. Unfortunately, an even more challenging situation is anticipated during the reading of batch 11 and 12.
There are so many challenges we are facing right now, including MCOs issues, work orders issues, the contractor issues. The MCOs arises firstly from the work order resolution. The contractors are making mistakes regarding work order resolution as they are not resolving the work orders, which create problems. If we resolve the work orders after replacing the old meter with the new meter, we need old meter's final reading, which is required for the consumer billing. And as far as this matter is concerned, the contractor has done so many mistakes regarding work order resolution, like they have installed the meter at the side, but they are not resolving work orders. Therefore, the system cannot generate the MCOs. MCOs are known as meter changing orders. The meter changing orders are created by the work order resolution. If work order not resolved, then MCO cannot be feeded, and MCO is a mandatory requirement, is a very mandatory requirement to feed into a billing system, in a billing system of revenue office. If the MCO not feed it in the system, creates so much problem, and this makes so much complaints from the consumer arises.
To address rising challenges, an image auditing system was put in place, where the readings of both the old and new meters were carefully checked to ensure accuracy. A filter was also used to find meters with 0 or negative readings and those with more than 400 units. Similarly, contractors were strictly bound to resolve all work orders. Simply replacing meters was not enough. True success required ensuring that the work is completed. One of the most critical steps in AMI project is moving data from old systems to the new one, known as data migration. The first step involves assessing the existing data, identifying where it's stored, and determining what needs to be moved. Careful planning is essential to ensure a smooth transfer. Teams are actively addressing challenges like dealing with outdated systems, ensuring data quality, and meeting legal requirements. Data is being carefully extracted from old systems, which includes metering system and billing softwares. Once extracted, the data is cleaned and formatted to fit the new AMI system. This step ensures consistency and readiness for use, but it requires careful handling due to differing formats and large volumes of data. The prepared data is then loaded into the new system, with careful management needed to avoid disruptions and ensure a seamless transition. Finally, the data is thoroughly tested to ensure it has been accurately transferred and that the new system functions as intended.
Actually, when we are going to move towards new system has its own architecture, its own schema, database schema, and we have to maintain the core status of our existing system. We have to move our current data into target system so that we can start from right from where we are running our activities. That's why we extract the data from legacy system and convert it into the formats which are required in new system. And these formats obviously differ from the legacy system because they are offering some different type of features, some different types of facilities, and different types of data analytics. That's why we require the data extraction.
So when we receive the shipment at Karachi seaport, so PTA takes some samples to check against the type approval we have already got for the meters. So when they verify it, they go or give a green signal to the customs that it is the same meters for which the type approval has already been taken, and custom can go and clear the shipment. So we have to collect those meters sample which collected by the PTA from the shipment, because those meters are our assets and we can utilize it in the field. So I'm authorized now going to PTA to collect those meters right now.
Before the shipment arrives at Karachi seaport, IESCO must secure several key documents. These include invoices and the Master Airway Bill MAWB, which provides crucial ship information such as the vessel's identification, route, and cargo specifications. The House Airway Bill further details the location of pallets on the ship, essentially serving as a blueprint for where the equipment is stored. Additionally, IESCO must receive a demand draft from the clearing agent to cover all necessary taxes, including those from FBR and PTA, ensuring the shipment can be cleared smoothly. A demand draft from the bank for the issuance of the financial instrument fee is also mandatory. If these steps are not completed before the ship's arrival, the delay could result in demurrages and necessary costs for holding the ship at the port.
Whenever the shipment arrives, all the stakeholders, they must be ready for it. All the documents, all the requirements which are required by the customs, they should all be prepared. So a lot of processes are involved in it, just like PTA and the PSQCA. And sometimes some documents are not ready, which delays the overall process of the custom clearance. Actually, 5 days are required, in which we have to clear the shipment, which is impossible for us. So the PSQC process and the PTA process, it almost takes 10 to 15 days. And after that, all other requirements such as disbursements of funds and issuance of FI and all those things, it requires much time from us. So one shipment, it takes almost 25 days to release. And maximum we are charged with 20 days of damage and few days of detention money. So it impacts the project, it impacts the financial cost of the project, and the overall taxes reach around 48%. So the custom clearance process, it should be very swift, and we have to work on it. And the government support is required, which can ease off this burden from the discos.
To resolve the issue of solar activation complaints, a new approach is adopted. Contractors now activate the solar feature on meters before installation, ensuring a stock of solar-enabled meters is always available for deployment where needed. This proactive solution effectively eliminated the problem, and since then, solar activation complaints have disappeared entirely.